Okay, so this is number 4 and 7.3. PC 27.3. So we have an absolute value just in one spot in the equation. So I'll do A first. So what you want to remember is that this absolute value means that there's two possible cases for what's inside the absolute value signs, where this quantity x plus 7 could be positive or it could be negative. The absolute value signs say we have to account for both possibilities. So what you want to do is, for A, you want to do two cases where we have x plus 7 equals 12. That's the positive version. And then technically, the second version would be negative x plus 7 equals 12, right? The negative version of what's inside the absolute value. But what we mentioned yesterday was that the negative on one side of the equation, multiplying by this whole thing, is the same as having the negative on the other side of the equation. And in many cases, if you have a constant or one single term, it's actually much easier to multiply the negative or apply the negative to the other side. So that's where yesterday we talked about making the constant positive or negative. It's the same thing as making the expression positive or negative. So we'll solve these two individually. And again, you'll always have two options when you have an absolute value as part of your equation. So we'll subtract 7 here, subtract 7 here, x equals 5. Okay, that is one possible solution. We'll have to check that to make sure later, but that's one possible value for x in the positive iteration or the positive version. The negative version, I'm going to solve for x here again by subtracting 7. This time x is equal to negative 19. So that's my other possible value for x. As we check that, I'm going to do absolute value of 5 plus 7 equals 12. Well, this is the absolute value of positive 12, which is equal to 12. That's true. The other one would be the absolute value of negative 19 plus 7 is 12. And this is the absolute value of negative 12 is 12, and that is also true. So these are two solutions to our equation there. Okay? So that's an easy one maybe. That's probably entry level. So let's do C. Let's do C. Because what happens if we have a multiplier here to the absolute value? Does anyone know what we would do if we have a multiplier like that? How do I deal with that?
Can't you just make the multiplier negative? Because if you'd multiply the same thing by a negative as well, and it doesn't matter the order that you would multiply.
Okay, can you make the multiplier positive or negative? Okay, that's a good question. So you're wanting to distribute this into the brackets?
Theoretically, you can.
So the absolute value signs, okay, it's a good question. Absolute value signs are like brackets, but they're kind of like supercharged brackets that make everything that come out of them positive, right? So if we're going to do two options for this piece in C being positive or negative, yeah, it would be like slapping a negative on the front for one option and then slapping a positive on the front for the other option. So, to your point, could you just make this 2 a plus 2 and then a second version be a negative 2? Technically you could. Yeah, technically you totally could. I would probably suggest, and this is the way that most students when they're learning this maybe want to do this, it's probably a good idea to try to get to this situation where you just have the whole side being positive or negative. That's what people default to. Your option I think would work fine. It would be totally fine. So let's do it the way that I think probably most people will feel comfortable doing it. And that would be to do a little bit of work to isolate the absolute value and then slap the positive negative. Okay, because that's like the other questions. But I think what I'll do is I'll do your version and we'll see if we get the same answers. Okay, so I would subtract 12 here and then divide that by 2 to get rid of these things. So that would be x plus 6 in absolute value signs. This would be negative 4 minus 12 is negative 16 over 2, okay, is negative 8. Ooh, okay. I got some alarm bells going off here right now if I did that correctly. What is the perceived problem here?
Absolute value can equal a negative number.
Yeah. So when you run into this situation where you have an absolute value on one side of the equation and this equals a negative value on that side, that should be red flags. Okay? So let's back it up. Let's back it up. Let's look at the original question again. For this left side to be equal to negative 4, okay, I would have to have, look at this is a plus 12 here. So this would have to be negative 8. Negative 8. This is a positive value times, this would have to be negative 4, right? If we think back to that. So this absolute value part would have to be negative for this equation to be true. So when you see this, you could probably say no solution. Now, we're going to verify the solution. So I think a good way to verify this would be maybe to plop this into graphing technology and just see if the two sides overlap. So let's do that. So if we graph these two, then what we see here, hey, is that the red graph, which is the left side of the equation, and the blue graph, which is the constant negative 4, they don't intersect at all, ever. So that means there's no solutions to this. So again, if you see this, you know you got a problem. Now, let's do what you suggested there, because I am very curious now to see what happens. If we just say, I'm going to slap a negative onto the 2 and solve, and a positive onto the 2 and solve, let's see what happens, because I think this is where we're going to run into trouble. So if I make the positive the first one, okay, and I make this a 2x plus 12 equals negative 4.
I just divided the two.
Sure, yeah, sure, that's fine. So then this is 24, so negative 28 over on this side. Is that right? And then 2x here. So x is negative 14. Okay. If you did that, if you did it that way that you suggested, I don't know if you would, I mean, you'd have to check this, right? This is the number you'd get. You'd have to plug it back in there and check to see if this is well. But there would be no alarm bells going off necessarily here, right? You just have a negative value. If you plug that in, let's see what would happen. Negative 14 plus 6 is what? That's negative 8.
That's positive 8.
So the absolute value brings out as a positive 8. So 2 times positive 8 is 16. Plus 12 is definitely not negative 4. So if you did this, you would have to make sure that you check this, and then you would have to reject it because it doesn't actually check out, okay? So can you do that? That's a great question. I would say yes, you could do this positive and then separately do a negative and then do the whole thing over again and get a different value. But you make sure you have to check them back to the original question. Yeah, so again, this would save you a bit of work, because right away you would know, you're right, this would save you a bit of work. So I would suggest isolating that absolute value expression first, just to check the positive negative thing. Yeah. Okay, anything to add or any questions?
In the Desmos graph, if you want to use a dotted line graph to extend those, you should get an intercept at negative 14 and a positive 2, just to see.
Right. Okay, good point. So if you go back here, if you actually, wow, yeah, if you extended this line here, right, to make this the positive version of this, extended this line here, you would get an intersection point at negative 14, yeah, right there. That's where that would extend to. And then this one would extend to somewhere around here, and it's a 2, is it? This is yeah. So then you would see those possible solutions. But because it's absolute value, the graph doesn't extend in those directions. So that's why you have to check. All right. Okay. Everybody good there? I would make sure that you solve for the absolute value expression first, and then check that negative, and then move on from there.